Hello everyone, welcome to Automation Community. In this session, we are going to see about normally closed contact. So, as I have already told, normally open contact is one of the important instruction in ladder logic. Same like normally closed contact is also one of the most important instruction in ladder logic programming. So, let's see in CX programmer. So here you can see this is normally closed contact. So I'll give the name which is a switch 0 already. So what is this normally closed contact? Why it is called as normally closed? If you see, there is a difference between normally open and normally closed symbol. Look at this. Look at this. This is normally opened. If you see, the normally closed is having one cross line from right to left. Have you seen? This is normally closed. So how it will work? So let's connect this with one of the output to understand this. So same tube light I am taking. We have seen this in the previous concept. The tube light I have taken. Okay. So imagine you have one normally closed switch at your home for the tube light. So let's turn on the main supply, which is I'm going online. Let's see, you have not done anything. You have not changed the position of the switch, but your output is on. Your tube light is on. Once you turn on the main, your tube light is on. Why? Why means there is a positive rail over here and a negative rail over here, right? So the power from positive rail is easily flowing through normally closed contact to reach the destination. Can you see? A normally closed contact is allowing basically the power to go through it. Alright. So, but in the previous session, we have seen about normally open contact, which is restricting the power to flow unless we change the position. But this is allowing. So, that's the difference between normally open and normally closed. So, initially it will be in the closed condition, which will be allowing the power to flow. If you change the state, the power will get restricted and your output will be off. So normally closed conditions, off condition is like this only. It is not that normally closed condition now in on condition, not like that. So normally closed condition is designed in such a way that it was in off condition, but it will allow the power to flow. It's like opposite to normally open contact. If you disturb the state of your normally closed contact, it will restrict the power to flow from positive to negative so that your output will get turned off. Understood? So what happen if I connect two normally closed contact in series? So let's see that also. Let's go online. Now see, both the inputs are allowing power to get through it and your output is on. Okay. Now change any one position, changing the position of switch 2. So your output is immediately turned off. Because both are in series, one is restricted means power is stopped here. Alright. So now I'll go back to the previous state. Now your tube light is on. Just disturb the state of this. What will happen? So power is restricted here itself. So power is not allowing from left to right. If you see switch 2, which is on, which is having some power, but without the power before this, nothing will happen. Power have to be cross switch 1 to reach the switch 2, but it does not happen, so your output is off. Okay. So now I'll turn it on, turn off it again. Now see, your tube light is on. Alright. So now I'm going to connect this in parallel. Let's see what will happen. That's it. Let's go for the simulation. Now as usual, both the inputs are in off state, but your output is on. So let's cut down one of the input, but it's not affecting the output because both are in parallel. Parallel means option. So if the power is restricted here means it will take this route to reach the tube light. See, there is no restriction in this line, so it is taking this route. Okay, so now disturb this. Now what is happening? So it is taking this route to reach the tube light. So this is how normally closed contact will get work. Okay, so what will happen if one normally open and one normally closed? So let's see that. So I'm going to use switch 2 as normally open and switch 2 as normally closed. Sorry, it's switch 2 as normally open and switch 1 as normally closed. Now see, your tube light is off. So I'm going to turn on my switch 1. Tube light is on. If you turn off the switch 2 or turn on the switch 1, tube light will off. Okay, so this is normally open and normally closed, and this is coil. So these three instructions will come under the bit logic. So all three are very important in ladder logic programming. I hope you have understood the normally closed concept. I'll meet you in the next session. Before that, kindly like and subscribe our YouTube channel for more updates. Thank you.